Drug strength and drug concentration mean the same thing. They refer to how much drug is distributed in a diluent. A diluent is just any kind of inactive ingredient that dilutes the drug. A solvent like water is an example of a diluent. Here the picture shows a solid drug up here that's dissolving in a solvent. When the solute and the solvent are combined, they form a solution. The solution has a greater volume than either the solute or the solvent starting volumes. To describe the drug strength of a medication, we usually report the amount of drug in comparison to the total amount of solution. So this amount relative to this amount. If you think that a comparison of the amount of drug to the total amount of medication will result in a fraction, you're right. Take a look at the pie chart on the right-hand side of this table. If our solution consists of 50 units of a drug and 50 units of solvent, the fraction that will describe the drug strength will simply be 50 over 100. That's 50 units of drug, and then the 100 is 100 units total. So that's 50 units drug plus 50 units solvent. 50 over 100 can be reduced to the fraction 1/2. We do that by dividing the top and the bottom by the same number. In this case, we divide both the top and the bottom by 50, and that gives us the reduced fraction. 50 can also be divided by 100 to give the decimal 0.5. The fraction 50 over 100 is also equal to 50% because by definition, the number of parts per 100 or per centum is the percent value, so 50. Another more common way to think about it is to take the decimal form and multiply it by 100, and that also gives you the percent. Now might be a good time to pause the video and make sure you understand the remaining relationships between decimals, percentages, and fractions on the table. If you do need a refresher on how to interconvert these values, you may want to consult the link at the bottom of the slide, which will take you to a nice tutorial from the Khan Academy. So go ahead and pause the video now and reflect upon the relationships in the table for a couple of minutes. All done? Welcome back. Hopefully the relationships between the fractions, percentages, and decimals on the table all make good sense to you. The next slide shows two different preparations that have a drug strength of 20%. This time we're including actual units that might be used to indicate the amount of drug and the total amount of prepared medication. So out of A or B, which of these measures of drug concentration do you think would represent the situation I showed in the first picture, where solid drug was being dissolved in liquid diluent? If you said B, that's correct. The units used in B best match those for a solid, which would be measured in grams, dissolved in a solution measured in milliliters. It's a 20 grams drug per 100 mils of solution. Situation A would be correct if the solid drug were dispersed in something like an ointment that might be measured in grams. The main message of this slide is that the medication may not always be a solid drug in a liquid solution. You could have a solid or liquid preparation, and the drug itself could also be a solid or a liquid. This next slide illustrates this further. It also points out that in concentrations, the default value for masses is grams. So anytime there is a mass, it's measured in grams, and the default value for volumes is milliliters. So anytime there's a volume, it's in milliliters. And so that's easy to see when it's written out in a fraction, like on the right-hand side, but not so easy to see when you just have a percent. So with percentages, we add the abbreviations W for weight and V for volume. So in the top example here, we have a 15% weight per volume. And so that you know, that tells you that the top part is going to be a mass, a weight in grams, and the bottom part, the total amount, is going to be in milliliters. The second one, volume, tells you that there's a volume for the top and the volume on the bottom. And then, of course, a WW would be grams on top and grams for the total preparation on the bottom. So let's look at a few different problem types that would involve calculating or using measures of drug strength. These have all been pre-worked out. We'll just talk through them. In the first problem, we're given a mass of sucrose, 10 grams, and we're asked to find, given a volume of solution of 90 milliliters, asked to find what the percent weight volume is. And so in this case, we just take the mass of the drug, which I guess is sucrose in this case, and divide it by the total volume of the preparation, the total solution, so 10 divided by 90, and then that gives us a decimal form, and we can multiply that decimal by 100 to get the percent form. The next problem goes in the opposite direction. We're given a percent concentration of the drug, the sucrose in solution, and we're asked to find a decimal value with units of grams per milliliter. And so the 5% weight per volume is 5 grams, because of the weight on the top, grams of the active substance in a total volume of 100 milliliters. And that's the definition of percent. So the amount per 100. And then if you divide that through, that gives you a decimal of 0.05 grams per milliliter. So in problem 1, we multiplied the decimal to get a percent. And in problem 2, we divided the percent to get a decimal. And the next problem, how many grams of sucrose are in 50 milliliters of a 10% weight per volume solution? So the first thing we can do is convert the 10% into its fraction form so that it's easier to deal with. It tells us there's 10 grams, the weight of sucrose, on top, and 100 mils of total solution on the bottom. And then we want to know how many grams of sucrose are in 50 mils of solution. And so this is, a proportion is good for calculating this. We can really just scale down the proportion that we already have, scale it for the amount in 50 milliliters. So we set those equal. You can crisscross and divide that through and get a value of 5 grams of sucrose being in the 50 mils of solution. In the last problem, we have a couple of different things going on. We're asked how many milliliters of solution can be made given a concentration of 7% sucrose. How many milliliters of solution can be made if we have 200 milligrams of sucrose? So the first thing we have to be concerned with is the units. We know the default unit for percentages for concentrations is in grams, and this amount is in milligrams. So knowing that there is in 1 gram 1,000 milligrams, we can set up a proportion to find out how many grams are represented by 200 milligrams. And cross multiplying, dividing, we see that there are 0.2 grams of sucrose. And then we can use a proportion, just like the one we did in the previous problem. We can set up the same kind of proportion to find out how many mils of solution that would result in, 7% solution. So the 7% is here in fractional form, 7 grams per 100 mils of solution, equal to 0.2 grams of sucrose. And how many mils of solution would that make? So we can crisscross. We can divide both sides by 0.2, and that will give us an X value of 2.86 milliliters of solution, of 7% solution that we can make from the 0.2 grams of sucrose. So the next slide that in the slide deck actually contains several additional problems for you to try. Do try doing these on your own based on the examples you've just been given. I'll work out the answers in the next video, but to make sure you really know how to do them, it's important for you to try doing them on your own before you see how I do it. So please give them a try, and then I'll see you in the next video.